Today we're going to be talking about equations and how to balance them. So I'm going to draw a picture to help explain how we balance equations. This is my seesaw. You could call it a balance, a scale. So, important thing to remember with the seesaw is whatever happens to one side of it has to always happen to the other. So I'm going to put an equal sign to represent my equation. So that's our rule that we always want to remember to keep it balanced. So whatever happens to one side must always happen to the other. So let's say I'm going to take and draw 5 oranges on this side of my seesaw. What do you think is going to happen when I put 5 oranges on one side and there aren't any on the other side? I'm going to show you. If we add 5 oranges to one side and 0 to the other side, what happens? That's right, it goes down on one side. Is it still equal? It's not equal anymore, because our rule is whatever happens to one side must always happen to the other. So, in order to make it equal, what do we need to do? We add 5 oranges to the other side. So, we're going to erase, draw it again, put 5 oranges on both sides, and that makes it equal. So this is what you do with algebra equations as well. Whatever you do to one side, you do to the other. And this is for if we're trying to solve for x. So I'm going to write a simple equation. I'm going to try this equation. X plus 7 equals 11. Now, the goal is to find out what x is. This is our mystery number, so we're trying to fill in for x. So, what we want to do first is split the equation up into 2 parts. So I'm going to draw a line down this equal sign, and then that gives us 2 different sides. So now we have x plus 7, and then we just have 11. Okay? Now our next step is to get x alone, because we can't solve for x if we have something added to it, so we need to get it by itself. So, what I'm going to do is I'm going to take this 7 away. Now this 7 is a plus 7, so we have to do the opposite of it to move it to the other side of the equal sign. So the opposite of plus is subtract, minus. So we're going to subtract 7 from this side, which is going to give us 7 minus 7 is 0. So it's going to give us a 0, and then it's going to leave the x by itself. So I'm just going to erase the 0 and just write an x. But what's our rule? If we do it to one side, we have to do it to the other because we have to keep it balanced. So, now that I subtracted the 7 from this side, I have to also subtract it from the 11. So I'm going to subtract it from the 11. And 7 subtracted from 11 is 4. I'm going to move my equal sign back down. Have we solved our equation? Did we solve for x? It says x equals 4. But we're not done because we want to always check our work. So in order to check your work, you're going to fill in for x. So we're going to go back to our original equation, which was x plus 7 equals 11. And if we found out that x equals 4, we're going to fill in the 4 for x. So we're going to write 4 plus 7 equals 11. And again, I'm going to split the equation into 2 parts. So I have 11 over here, and I have 4 plus 7 on the other side. And what is 4 plus 7? It is 11. So does 11 equal 11? Yes, it does. That's how we know that we got the right answer. Now, the equations aren't always this easy. Sometimes you have a number subtracted, so we're going to try another equation with the different numbers. So, let's try this one. X minus 4 equals 2. So what do we do first? We're trying to solve for x, so we're going to split the equation up into 2. So this side will just have x minus 4, and this side is just going to have 2. Now next we want to get the x by itself. So right here we have x minus 4. So we do the opposite of minus 4, which is plus 4 to get the x by itself. So we're going to add 4. And that's just going to give us x because minus 4 plus 4 is 0. And then over here you're going to add 4 as well. Because whatever you do to one side, you have to do to the other. So we're going to add 4 to 2. That's going to give us 6. And then again, that gives us our answer. X equals 6. But we always have to check our work. So we're going to plug it back in for x. Original equation was x minus 4 equals 2. So we're going to plug the 6 in for x. So 6 minus 4, 6 minus 4 equals 2. I'm going to split it up. 6 minus 4 equals 2. And on the other side we have 2. Does 2 equal 2? Yes, it does. So that's how we know we got our question right. Now what happens when you add a variable to x? It makes the question just a little bit more complicated. So we're going to try one with another variable added to x. We're going to try 2x plus 3 equals 7. Now this adds another step. But we're going to start the same way we always did. We're going to split it up. So we're going to have one equation over here that says 2x plus 3, and the other side's just going to say 7. And our goal is to get x by itself. So we have the plus 3. And what's the opposite of plus? Is minus. So we're going to subtract the 3 to get the x by itself. Plus 3 minus 3 is 0. So we just have 2x by itself now. But whatever we do to this side, we have to do to the other. That's our rule. So over here we're going to also subtract 3, which is going to give us 4. 7 minus 3 is 4. But wait, this still says 2x equals 4. But we still have another variable over here we need to get rid of. Now the 2 next to the x actual means 2 times x. So what's the opposite of multiplication? It's division. So we're going to divide this by 2 to get rid of the 2. But whatever we do to one side, we have to do to the other to keep it balanced. So we're going to divide this 4 by 2. And what is 4 divided by 2? It's 2. So we found x. X is 2. But we're going to check our work. We're going to plug the x back in the original equation, which was 2x plus 3 equals 7. We said x was 4, so let's plug in the 4. Remember we said this 2x was just 2 times a number. So we're going to put parentheses to show for times. Plus 3 equals 7. Let's split it up. We're going to have 7 over here. X. 2 times 4.
X was 2, not 4.
Was it? Oh, you're right. Thank you. You corrected me. Okay, so 2 times 2 is 4 plus 3. 4 plus 3 is what? 7. So we got 7 equals 7. Then we know we got our x right. Okay, so let's try one more equation. We're going to try one of these with the extra variable but subtracting. So we're going to have 3x minus 5 equals 1. This is going to be our last equation. So what is always our first step? We're going to split it up. We're going to split right down the equal sign. Have 2 different sides. So over here I'm going to have 3x minus 5. And over here I'm going to have 1. Now, we have 3x minus 5. 5 is the extra. It's minus 5. So we need to take this 5 away. We're trying to get this x by itself. So the first step is to take the 5 away. So what's the opposite of subtract? Add. So we're going to add 5. I'm going to add 5 over here. That still leaves the 3x, but minus 5 plus 5 is 0. So that goes away. But whatever we do to one side, it's a rule. Whatever we do to one side, we have to do to the other. So we added 5 over here. We're going to add it over here as well. So 1 plus 5 is 6. Are we done? No, we still have a 3 multiplying times this x that we're trying to figure out. So what is the opposite of multiplication so we can get rid of this 3? Division. So we're going to divide by 3. But what's our rule? Whatever we do to one side, you always have to do to the other. So we're going to divide this side by 3 too. So 3 divided by 3 is 1, so it just leaves 1x equals 3 divided by 6 is 2. So x is 2. But we still want to check our work. Always check your work. So we're going to plug in for x. Our x is 2. So there's our original equation. Remember this 3x was just 3 times x. So now that we know that x is 2, we're going to write 3 times 2 minus 5 equals 1. Now 3 times 2 is what? 6. Minus 5 equals 1. 6 minus 5 is 1 equals 1. Does 1 equal 1? Yes, it does. That's how we know that we did our equation right. Now these equations get more and more complex as we go, but it's always important to remember that whatever you do to one side of your equation, you do to the other. And you can draw the scale if it helps, and draw little oranges to represent your numbers, and then just fill in for x as you go. But it's important to always remember this rule to keep it balanced. Whatever you do to one side, you do to the other. And always, always important to check your work. Always fill in for x so that you make sure that you did your equation right. And that's the end of our lesson.